everybody. My name is Peter, if you don't know my name yet. So far, we've taken a look at two different ways that we've kind of classically developed these predictive models. And, how many of you guys had prior experience with Python and R? Right? So like a good part of you, and the other half has not. So if you looked at all that code, it would seem to be like a lot of effort to kind of code out the model and tell it to do exactly what you want it to do. And Microsoft realizes that a lot of, at least smaller businesses, don't have the data scientists to kind of build out those predictive models. So they've been trying to make improvements. They've been trying to make improvements to kind of make the process easier to develop a model and just kind of make it more accessible to everyone. So the platform that I'm sure some of you might have heard before is Azure Machine Learning. The actual platform is now called Azure Machine Learning Studio. So if you're looking for the program, that's what it's going to be called. Now, as for what Azure Machine Learning Studio is, it's basically their attempt to kind of streamline the process so that you're going to reduce the time from designing and then you can shorten the time to deployment. It takes advantage of the existing Azure infrastructure cloud that they already have out there, and it basically empowers them to kind of just empowers anyone to deploy their own models. Now, so here's an example. Before it was basically the goals of what Azure Machine Learning Studio achieves, but this is what it actually looks like. So here are a couple of screenshots. On the right is a screenshot of Henry's model. Obviously not the whole model, couldn't fit it in one snapshot, but basically the same model. Even if, I'm sure if you have experience with Python, it would take you some time to look through that screenshot and kind of figure out what exactly is going on there. Whereas you can look at the model on the left coming from machine learning and kind of quickly get a grasp of about what's going on. So this becomes really powerful for the end user. The interface, rather than focusing on coding where you can kind of run into a lot of small issues like typo and you got to rely on the IntelliSense, you can kind of just click and drag and connect the different modules together. So you can focus more on the designing aspect of a model rather than get caught up in the small stuff. So the smallest working unit in Azure Machine Learning is the module. And here's just like a small subset. Now, Azure groups a bunch of different modules together based on their kind of general functions. Input, output is how you import and export files and data. You have your transformations, statistics, and machine learning modules. These modules are basically tasks or actions that Microsoft kind of identified as very everyday use case. And so they kind of pre-made some code that you can just kind of drag and drop and use them as the blocks inside your model. Every single code, might be a little bit difficult to see here, but if you notice, the cleaning missing data module has one input and has two outputs, whereas some other one like summarize data only has one input and output. Every module has been specifically coded to take in one data type as an input and spits out a certain type of output. So it's specific to the task that you're doing. Along with inputs and outputs, the parameters that you can pass through each module is also unique to it. So there's a few modules that I kind of want to bring to your attention as a little bit more interesting. When you're working with Azure Machine Learning Studio for the first time, you're going to have to get used to a kind of weird approach to your problems. You're going to have to break down every step you're doing to the smallest increment. To give you kind of like an example is like, let's say you had a data set that was for some reason all imported as strings, but you had some dates in there, you have some quantities, and you got to change the date time. You got to use a separate module for each transform that you're going to make. Whereas if you're coming from like a SQL background or something, you can typecast them all in one select statement. So if you have some SQL background, you can leverage that knowledge, and instead of using like the different individual modules, you can just use an apply SQL transform statement. And this is what a parameter screen looks like for that particular module. You just copy and paste your script, and when you run that code, it'll run that transformation. One thing to keep in mind is that you're not just running SQL. Even though it is a Microsoft product, you're not using T-SQL. The engine is actually SQL Lite, and that kind of lends its own challenges if you're not used to it. So SQL Lite, if you're not aware, it's basically kind of a stripped-down version of SQL, kind of meant for more mobile platforms. It's supposedly faster, just more focused on file transfer. Some things to kind of keep in mind are that it uses dynamic typing. If you remember from Python, it can cause some issues because if you're importing data and then you do these transforms, it's going to make some assumptions. Now, this sometimes can be very convenient, but if you're trying to do some kind of operators like adding numbers together, decimals and integers, you might not get your expected value. So you do definitely want to make sure you're kind of checking that the transform is doing exactly what you want it to. Some other kind of statements are different in SQL. You can use things like left outer join, but right outer join and full outer joins are not valid statements that you can use. And same things for the alter table. You can rename your columns, add columns, but you can't drop columns for some reason. If you're using any views, they're only going to be read-only, so you can look at your views, but you won't be able to make any changes to them. I can't emphasize enough that you definitely need to kind of look back and make sure the transform is doing what you're telling it to do. One kind of finicky thing with the SQL Lite, since it's running in the background, if, for example, you are trying to concatenate some strings together with like a plus sign operator. A plus sign is a valid operating tool that you can use in SQL, but in SQL Lite, you can't concatenate strings with a plus sign. So what's going to happen, take, for example, you have first and last name, and you try to do a plus sign between them. Your output is going to be a 0 instead of giving you an error, because plus signs are valid, just that operation's not valid. So if you're trying to like concatenate a bunch of people's first and last names, like customer-wise, you're just going to end up with a result set of a bunch of zeros, which could really mess up your data if you don't catch it kind of like right away. You'll see later on in the demo that Azure makes it really easy to kind of visualize your data as you go, and I'll go ahead and demonstrate that in a little bit. All right, so another huge script here is the use R, execute R in Python scripts. So, you might be thinking, with all the different modules available to you, why do you even need to know how to code? So the purpose of Azure Machine Learning is to make the process easier. It's not to make all the existing data scientists unemployed. You definitely still need them around. And if you have coding in Python or R, you can definitely leverage that and flex it here. So basically, there are some use cases where you definitely need those programming languages. And to give you some examples, if you're working with a client and they want you to come up with a predictive model, linear regression won't cut it, decision forest won't cut it. You just gotta kind of come up with something in-house custom. If Microsoft hasn't identified that as something that everyone uses or hasn't made a module for it yet, you could just make your own code, click on one of these scripts, and then put it in there. And then when you connect it inside your model, it will run that code with the data of whatever you input into it. Another huge thing that you can do is visualizations. So Azure Machine Learning is more of a predictive analytics tool. It's not really built for descriptive analytics. So if you try to want to make a nice graph and kind of take a look at it, you are probably better off using like Python or R to make those graphs for you inside your console. Reading from other data sources, we'll cover them a bit, but the sources that you can use with Azure Machine Learning are a little bit limited. You're not going to be using your typical CSV files if that's a very common type in like Python and R. And just in general, if the task that you need at hand, there might not be a module for it yet. So splitting columns, that's like the opposite of what I was saying before. Let's say you had a full name and you want to put in the first and last name. There isn't a column already made to make that easy. So when you're working with these modules, one thing you have to keep in mind are the inputs and the outputs. So when you're taking data from your Azure Machine Learning and you want to put it into these scripts, you got to make sure that it's in the form of a data set. And a dataset is just an object that is commonly used inside the machine learning platform. You can have up to 2 data sets, and for the outputs, you always have to make sure the output is going to be in the form of a data frame. So what that kind of means is that you'll see that when you're writing your Python or R scripts, you run the script and usually get some kind of output. You just got to make sure that that output is going to be a data frame. And the reason why that's so important is, we'll get that in a second. But it's a data type issue, and we'll cover that in a sec. So it's kind of hard to talk about R and Python without speaking about the different kind of packages that you're using. When you're using Azure Machine Learning, it comes pre-installed with hundreds of packages, similar selection as what's already in Anaconda 4.0 and Microsoft R Open. Being installed doesn't mean that it's ready to use. You still have to call upon it, but when you do, it's already in there. You don't have to do anything fancy to access those packages. If you need something outside of what's available that's pre-installed, you can add that in. It just takes a little bit of an involved process, a little bit more than what I'm going to cover here. But you just got to remember that if you want to do some like bonus packages, they can't have any Java dependencies, and they can't be required to connect to the internet or a network. On the right, it's a small collection of packages that are pre-imported. So math, numbers, date, time. Typically, people are finding that if you're going to be using Python inside Azure Machine Learning, you're going to be using these anyways, so they don't require you to explicitly write import pandas. So now we're getting to the data types. So we try to group all the data types to kind of meet every line is like an equivalent. One thing you'll kind of notice is that when your list is a type that's really commonly used in Python and R, but it's completely absent from Azure Machine Learning. So you have to kind of keep that in mind when you're trying to export data and import data to and from Python R. Another thing that is notable would be the complexes. Complex numbers, they're recognized in Azure Machine Learning, but not by all the modules. There's certain modules that can have some issues when you're working with complex numbers. So if you run into that issue, just keep in mind that that could be a root cause. Another section here is notice that next to data frame and data set. So this is why your output for R and Python scripts have to be in the form of a data frame. Because when you put the data into a data frame, it will get implicitly converted into a data set, which is the normal object that you use in Azure Machine Learning. So since we're kind of on that subject of compatibility, I thought I'd take the chance to talk about the connectivity. It is part of Azure, it's an Azure product, so it has really good connectivity to the other services inside Azure, notably blob storage, Azure Tables, and Azure SQL databases. They work pretty seamlessly. There's pre-made modules specifically to import and export from those sources. If you worked with Hadoop, you get just as much functionality from them as well. If you're working on a client that is still using a on-premise SQL Server database, you can also import their data, but just keep in mind that you can't export data back to them directly anyways. You can probably kind of finesse your way around that. That is a preview feature, so it's kind of, it's in beta or pre-release, but it is something that will probably get eventually added in the future. Some cool things that you can kind of do is, if you know at the top, you can connect to a web URL. What you can actually do is you can import data from specific websites, and you can record like behavior patterns, traffic, and you can run advanced analytics on that. That's something that you could be doing if the client is a little bit more advanced. So next we're gonna kind of go into tiers and pricing. So Azure Machine Learning is it's a nice tool, but at the end of the day, it's a service, so Microsoft wants to make money off of it. So there's basically 2 tiers for the actual studio, free and standard. Free is free. You don't even need an Azure subscription to use machine learning to try it out. So if you guys are interested, it's super easy to sign up for. If you're going for the standard, you're going to have to pay $9.99 per seat per month. So basically, you can share your workspaces. So if you're going to share a workspace, you need to pay per person per month. And when you're doing your actual experiment, it's $1 per experimentation hour. As for most free and premium services, you'll see your normal benefits like performance boost. And so in a free version, you get 100 modules per experiment, basically 100 steps, and you have a runtime of 1 hour max for your whole entire experiment. Now, 1 hour is, if you've never built a model before, 1 hour is very small. If you're building something super complex, for what we're building, it's going to run in a few seconds, but once you build it out, you kind of see that it becomes a bottleneck if you try to rely on the free, which we shouldn't be relying on. If you look on the standard version, the cap is 7 days per experiment, and per one module is 24 hours. So since that is kind of like the max of what's available, you can kind of see how long these experiments can eventually get. Storage space. Storage space basically just kind of refers to how much data you can upload into Azure Machine Learning. It comes as a little bit of storage for you to upload your data sets. It's unlimited and paid, but not really. It's based on what you're willing to pay. So you can have a ton of space as long as you're willing to dish out cash for it. Performance-wise, again, you're going to be doing one node, so basically one step at a time in a free version, whereas in the paid, you'll get multiple nodes, which ends up being faster. And APIs. APIs is the big one here, because at the end of the day, you're going to be building this model, and it's going to be giving you predictions, and it has to be, you want to be able to consume this model somehow. You're not just building it to build it. So if you're building it for like an end user, you want to make sure you're going with the paid version, because Microsoft is going to give you like a production level API with a service level agreement. Basically, Microsoft is like guaranteeing you that this API is going to be up and running like 99.9% of the time, and you're not going to be getting that with the free version. So you don't want to use a free version, have your API crap out on you, and then you're in trouble because it's your fault. So back to the APIs, you're going to be consuming them via RESTful APIs. RESTful is just kind of like an architect. It's a style of API. When you build it, you can connect it to basically any programming language that uses HTTP request response. It's just kind of like a mode of communication. Microsoft is really pushing the use of Excel Online and Excel add-ins. Basically, you can create your model in Azure Machine Learning, and then like literally minutes later, you can consume it inside your Excel sheet. There is also the option of using some Microsoft's pre-made web app templates. So if you want to build like your own custom application on a website, you can build it out, connect it to your API, and then you can use that website or web app to actually spit out the results and use your model. And so back to the business side, the API also has its own web tiers of pricing. So before, the other two tiers are based on like designing your experiment, and this is how you're gonna be consuming it. So basically, different levels means you can run more transactions against your model at any given time, and it can compute those calculations. You have a longer time of doing that. So this would only be important if you just need to consider your target audience. If there's something like, say, Amazon, you're putting it on a World Wide Web where everyone can use it, you're going to be wanting to go to a bigger package. But if you're trying to deploy something, say, within the company and not that many people are going to be using it, smaller package will work fine. So I'm going to go ahead and go into pros and cons. For pros, there's a lot of different tiers, which means it can be confusing to navigate, but once you kind of get the hang of it, means you can really tailor your experience and pay just what you need. It's kind of the whole cloud, just use what you need and you don't have to waste. The user interface is completely drag and drop, which you'll see later. You can literally build it with one hand, which I'm probably going to have to do. And it runs off the cloud. It literally runs out of a web browser, and all the computing power is not on your computer, which is fantastic. Because if you can literally run off of a computer that has a processing power of like a toaster, and your model will run just fine. Another huge thing is that because it's not running off of your machine, last week I was running an experiment, ran for like 40 minutes, and then my computer crashed. And then I came back on and it was done, and it was like the best feeling. So you don't really have to worry about your computer is not a bottleneck here. It supports R and Python code, so you can take advantage of your existing knowledge. And the web service is super easy. I brushed over it briefly, saying that it only took a few minutes, and that's huge. You can talk to, say, Alex. I asked him, how do you make a web service in R? And he's like, I don't know. So I don't expect anyone else to know. And retraining your model is also super easy too. Your model is only as good as the data as you put into it. So as you collect more data with your model, you can actually take that data and just kind of like inject it back in and rerun your model. The platform is completely closed source, so it's kind of like the opposite. There's not as much transparentability. You just kind of have to trust that the modules are doing exactly what you want it to. And this can have some issues later on in terms of performance. I've talked to a few people that have actually used Machine Learning Studio, and the general consensus seems to be that it's a little bit slower to run your models. And that's probably because it's closed source. The code, if people have come up with ideas to optimize, like in Python with their packages, you can't do that with Azure Machine Learning. The algorithms, there's fewer of them made, so you guys got to rely on Microsoft. You send in stuff into their backlog and hope that they create a module for it later on. And customizability. If you don't know any Python or R code, you're going to run into a lot of issues if you're trying to make something any more complex than what they have right out of the box. You're going to be relying a lot on Stack Overflow for that. For a platform that's so focused on making everything visual for you, model visibility is very, very poor. So what I mean by that is if you're running these models, keep in mind, for a standard package, the max for a particular module can be 24 hours. So imagine you're running this module and you're getting there to like 16 hours and then you're sitting there the whole time. Is it going to work? Is it going to fail? Is it even the right thing to do? You have no sign of a progress bar. So it can be kind of spirit crushing, but that's just one thing you're going to have to take. All right, so next I'm going to go ahead and jump into the demo here. Brian emailed out a file and set of instructions. I probably should have reminded you guys that at the beginning, but if you guys have that, it'd be cool for you guys to open it up. All right, so I'm going to take you guys from basically step one. If you don't know the website, it's studio.azureml.net. And as far as I can tell, everybody in this office has probably or is signed into Office 365. So if you just go on the azureml.net website, there should be a sign-in button. So go ahead and sign in into that, and I believe it should just kind of jump you into this screen. Feel free to let me know if you guys have any issues on that. All right. So this is kind of like the landing page of where all your experiments are going to stay. And so one thing I mentioned earlier is that Azure ML doesn't run off of CSV files. It runs off of datasets. So it doesn't turn out to be a huge issue because you can easily turn a CSV file into a dataset, and you just do that by pressing this new. And it'll give you some options here. Just go ahead and select dataset and from your local file. So just go ahead and browse your computer for wherever the file is. Give me a second. All right, so go ahead and select your file, click open. If this is the first time you ever open this file, just go ahead and make sure that this is a new version is not checked off. And for a name, you can literally enter in anything you want. So I'm just going to do AWA MPG, super original. And make sure that the CSV file, it should auto-detect CSV, just make sure it does, and hit the check mark. And then you'll see here a little thing that's telling you that it's happening, not how much progress is happening. But once it's there, we will, again, I'm going to be doing this off the free version, so it's not going to have the best performance, but it's just to show you that anything is possible. Go ahead on the left-hand side, click on Datasets.
Still uploading.
Oh, still uploading?
No.
When it,
It says upload.
yeah, you'll get this little check mark when it's done. When it's done, on the left side, go over to Datasets. And if you've uploaded it, it should appear here. And that's about it for making a dataset. All right, so next thing we're going to do is go ahead and click on New, and then this time click on Experiment, and click on Blanking Experiment. And then this is basically your main workspace for when you're creating a model. Up here you have, it says Experiment created on 4/13. You can go ahead and rename that to whatever you want, and you can do that anytime. So, all right. On the left-hand side, you're going to be seeing all the categories for the different modules. If you expand them, you'll see like exporting and importing the data. What we're going to be doing to start is go under your Save Datasets and go to My Datasets, and go ahead and just drag one of the modules out onto the screen. And congratulations, that's your first module if you've never done this before. And basically, the rest of the process is not much more complicated than that. Something that's really cool with Azure is that you can right-click on the module. You can do it in the circle or just on the block. Go to Dataset, and you can visualize. So what this will let you do is basically look at your data, look at whatever's inside. You see all the values of individual rows, and as well as all the different columns that you have. Another huge feature is that if you click on a particular column, like year, for example, you get some statistics on the side. Here you see unique values, min, max, median, not mode, feature type, so it's a numeric. Missing values is like huge. So if you explore through the different columns, you'll notice that horsepower has 6 missing values. Now, since we're going to be running a model off of this data, we can't have dirty data. We're going to at least try to clean it. So let's go ahead and try to remove those missing values. So you can basically get to your mods in one of two ways. One, you can try to locate them manually. Go to Data Transformation, go to Manipulation, and Clean Missing Data is a module that you can use. The alternative is if you've already used it a lot and you just know the name, you can just type it in to the upper left. It kind of tends to be a little bit faster if you're used to it. So in the Clean Missing Data mod, what you're going to be doing is take the output of your original MPG file and just connect it to the input of your Clean Missing Data module, and inputs are on top, outputs are usually on the bottom. So once those two things are connected, basically you're going to be clicking on Missing Data module, so you can get some parameters that are specific to only this module, and we're going to try to configure some stuff. So when we're cleaning missing data, we want to click what columns to be cleaned. So it's currently selected on all columns, but we don't want that. We just want the horsepower column. So this is another thing to get used to. Best advice, if you're trying to select a few columns, start with no columns and then just choose what you need. Whereas if you're trying to select a lot of columns, go the other way, but it's up to you. So I'm going to begin with no columns, and I just want to include, go to column names and type in horsepower. And a really small thing is just make sure you press enter after you type it in. You want to make sure you see this little blue box here. If you just type in horsepower and you click the check mark, it's not going to work. So make sure you get that blue box around whatever you're typing in. So now it's selected just horsepower. And basically what you can do is what do you want to do with the missing values inside horsepower? They give you a bunch of different options. What we're going to do is trying to keep in suit with everyone else and just do replace with median. And what you can do to kind of test that real quick is to just run it. And something that's really cool about Azure Machine Learning is that every step you take, every time you run it, it will cache your previous steps. So here we see they gave us an indication that this was done. This was our original data set. Right-click, visualize that, and you click on horsepower, and you'll see it's missing 6 values. We make it run into a clean missing data mod. We can right-click on that, and then visualize that data set. And if we click on horsepower, it's missing 0 values. This ends up becoming huge if you're trying to troubleshoot, because you can actually really kind of drill down to where things hit the fan and figure out where your model went all wrong. So another thing that you notice in the R and Python demo is that they removed the name column. So what we can do here is in data transformation, manipulation, same tab, go ahead and click and drag a select columns in dataset and put that out onto the main screen. For this scenario, take out the left output of cleaning missing data and drag it into the input of the select columns. And here we will have your column selector again. And this is kind of like the opposite. We want to basically choose all columns to use except for name. So I would go and click all columns, exclude name. And then it'll just let you know here. So at this point, we clean the data. We took out the nulls, took out name. Another thing is that origins, currently it's labeled 1, 2, 3, and it's using it as like a normal value, but we want to treat it kind of like a place, right? We don't know what the places are, but we know that 1 is a place, 2 is a place, so make it a category. So another thing that we're going to go ahead and do is go ahead and drag a edit metadata mod. It's in the same exact location as the other ones, and we're going to connect the only output and input together. Click on edit metadata, and what we want to do is launch the column selector, and we only want origin. All right, once we go to origin, we can click here and click on categorical, make categorical, and basically that's as easy as that. You can go ahead and rerun it if you want. It might take a couple seconds, so it's basically just going to run through all these steps, and then we can go ahead and confirm. And I kind of missed it, but I skipped the missing clean data. It's just kind of proof for you guys. All right, so with the missing data, at the end of all these steps, we are now don't have a name column anymore. Origins is now categorical. Horsepower has 0 values that are missing. So as for like data cleansing, that's basically all we're going to do for right now. Going back to kind of what Brian was saying with training and testing your data, machine learning makes it super easy to do that as well. Close the manipulation tab and open up sample and split, and there is a split data module here. Go ahead and make the necessary connections and click on the split data. Change here, basically it's saying that it's splitting the data 50-50 to the 1 and 2 outputs. So we're going to change it to 80-20. And just like for normal conventions, it says result dataset 1 and result dataset 2. This is the 80 and the 20. It doesn't explicitly say this is your test training data, this is your testing data. Just for convention, I usually do training on the left side, testing on the right, and you can easily switch that, but I don't see why you would do that. For the actual model building, we don't have to really code anything. Just go close all your tabs and go down to machine learning, and we're going to do a little bit of rapid fire here. Open up initialize model, go down to regression, pull out a linear regression mod, go ahead and close that, open up a training category, and take out a train model module, close that category, go to score, get a score model, and take out and evaluate under the evaluate tab. And the main reason I kind of just pull these out is when you're kind of building these models, very rarely will you be using one of these mods without the other. All right, so one thing I want you guys to take a look at is click on your trained model and kind of hover your mouse over the inputs. So one side says untrained model, and the other side says datasets. So the inputs are specific to one function. It's been coded that way. And if we go to linear regression, hover your mouse over it, it outputs an untrained model. So you can kind of like put 2 and 2 together, put the untraineds together. But kind of Azure takes it a step further and try to baby-proof it, and you can't even make the wrong connection because every input and output is specific to what it can take in. Another thing that I want to point out to you is that notice in the score model, if you hover your mouse on the left input, it says trained model. Now, if I go back to the linear regression with an untrained model, it will still allow me to make that connection. So basically, when you're kind of looking at these names, you just got to be careful. The first word is usually some kind of adjective to kind of describe the object, and the second name, like model, dataset, is the actual object. It's kind of up to you to kind of make the proper connections with one another, but it's kind of like a data type. All right, so we're going to go ahead and just make all the connections first and foremost here. We'll take the training data from split, which is going to assume is the left side, and put into the train model. We're going to take the right side, which is the testing data. We're going to put it into the score model, so scoring with your testing data. Connect the train model with the score model, and finally the score model with the evaluate model. And then when you zoom out, it should kind of look like that. One thing I want you guys to go ahead and do, go back to the split data module, and for the random seed, put in 1, 2, 3, just so we can kind of all get the same answers, same results. All right, so now most of our mods are basically all connected, so we're going to go ahead and configure them. So jump into your linear regression, and here you'll see ordinary least squares as your default. We're going to change that to online gradient descent, and we'll keep these values basically the same, except turn off these 3 checkboxes here for right now, or actually turn on normalize. Turn off the bottom 2. For the random seed, put in 1, 2, 3, and then for the train model, we're going to go ahead and select the column. Inside the train model, that's when you are actually picking out what feature you want to be predicted. So we are basically trying to predict miles per gallon, so that's what we're going to be putting in here. All right, score model doesn't have anything, and evaluate model doesn't have anything, and go ahead and run. So this is where you're going to probably see a little bit of that performance. It's a pretty small model, and it's going to take probably about 30 seconds. So let me just kind of go in through a few things here. A linear regression, that block is just to tell you what model that you're using. The training is how you're going to train it to give you the results that you want. Score and evaluate can be a little bit more confusing. Score is when it's taking your model and actually giving out results for every input that you put into it, but it doesn't tell you like how many percentage you got correct or wrong. That is what comes into the evaluate module. That's why you need it. So give that a sec here. So now everything is all run. We can go down to the evaluate module, right click it, and we can visualize that. And it comes out pretty good, comes out to a 0.82. Just notice earlier that everyone was using kind of different factors for errors. Depending on your project or whatever you're doing, you're going to be wanting to use a different kind of error, but just for the sake of simplicity, I'm going to be using coefficient of determination as a proof of concept. All right, so one thing that you can actually kind of change around is the parameters for linear regression. We have learning rate, which we kind of explained earlier, is the steps, and number of iterations, basically the number of steps. So this is only taking 10 steps, and it's already getting pretty good. You could manually go through and copy and paste and do a bunch of different combinations. If you're following the document, if you're interested, I have a section called Tuning with Hyperparameters, which kind of showing you how I got to a specific answer out of thousands of different combinations, but I'm just going to exclude that for now and kind of give you guys the right answer just to cheat. Something we can do here that is really specific, that's kind of cool, is you can draw a box around your modules so that those 3 are going to be highlighted, and you can copy, paste. And then you just have another copy of basically that model. And if the modules are kind of adjacent to each other, then the connections will stay the same too. So let me just go ahead and just rearrange this a little bit, just to make it a little bit easier to see. And if you're using, I'm going to try to fix all the connections with all the modules. So we're going to take this training data, connect it to the training, take this testing, connect it to the score, and then we'll connect the score model to the remaining evaluate model side. Notice that for outputs, you can connect it to multiple different inputs, not a problem. For the linear regression, just go ahead and change the learning rate to 0.66949.
Oddly specific. Everyday numbers.
And then we'll just change the number of experiments to 100. And everything else should kind of stay the same. And if we run that, it's going to take another 30 seconds. So I probably... Anyways, when there are modules out there that kind of help you zero down on what specific numbers. I didn't hand pick that number and get it. That module does take a lot of computing power, but once you learn how to do it, it becomes like a really powerful tool. This whole left side is going to just be done because it's already been pre-run. The right side is what is kind of the new thing here. So we'll let that run through. And
so while that's running, so Peter's comparing two different models, right? But there's another way you can use the two inputs to evaluate model is to score the model with your training data as well as your testing data and put both of those into evaluate model, and then you can see if you've overfit. So that's another common way to use the two different nodes on evaluate model.
OK, so everything has run. You can go to the evaluate module, and then we'll quickly visualize that. And you'll see just comparison. So I went through a lot of effort, but if you see the number of coefficients kind of increase a little bit, that's not to kind of underplay that. When you're working on different models, definitely you want to try out all your different combinations of learning rate to try to figure out what's best. If you're trying to use that model to like make money, it's kind of important. So once we finish making this experiment, we want to go ahead and try to put it into use. So if you have multiple modules like me, you're going to have to click on what training module you want to put into production. So I'm going to use the right side because it's a little bit better. Click on Setup Web Service and click on Predictive Web Service Recommended. And it's going to rearrange the basically experiment into like what it's going to be used in production. If I can, I'll just go ahead and just kind of try to untangle the mess here. If you're trying to use this, try not to change things around too much. One thing I want you to go ahead and do is take this last relationship between the web output. I want you guys to go ahead and delete that and bring in a select columns in Dataset. And that's just a little pro tip from me. Makes your results a little bit prettier. And then for selected columns, click on Launch Column Selector. And you're going to do no columns except scored labels. Scored labels is just a generic thing that it uses for the prediction. And then click OK. All right, so before we can do anything with this model, we have to run it again, just as a test run. It wants to make sure that everything is all good and dandy before you put it into production. So we're going to have to run it again, and it's going to take roughly about the same time, probably about 30 seconds. In that meantime, open up a new tab and just see if you can open up an Excel. You can do Excel on your computer, Excel online. Either of them work. And open up a new workbook. All right. And since that's still loading over there, we'll go ahead and get your plugin kind of started. So if either platform you're using, go over to the Insert tab, and there should be an Office add-in, or if you're on your computer, it should say My Office Add-ins. We'll let that load. And then so this is already here, but if you don't have it, go over to Store, and you can do one of two things. You can either type in Azure Machine Learning, or you can just go to Data Analytics, and it should be right there. Click Add, and you'll have this little pop-up on the side. Click on Add Web Service, and we have two blanks, a URL and API key. Just kind of leave that there for now. Go back to your experiment if you're running it, and you'll see that everything ran OK. So we're going to go ahead and deploy this model. And you'll see that basically that's all it really takes to kind of deploy it. So now the model is up and ready to be used, so all we have to do is use it. Click on Configuration real quick and turn on Enable Sample Data. That's just for a little demonstration in a sec. All right, go back to your dashboard and click on New Web Service Experience. It just takes you to another page where they manage all the models together. Wait for your ribbon to load and click on Consume. And here, this is the page where you have all the information you need to consume your model. This is like code if you want to put it into one of your programming model codes or whatever. Up here, these are what we want from right now. So this primary key, go ahead and click this to copy. And basically, your primary key will be your API key. So go ahead and just copy and paste that into your API key. and then take the request response and copy and paste that into the URL and click add, and the model is in your sheet. All right, so some interesting things is view schema. Basically, this is the way your inputs are going to be configured. The first column is going to be a number, integer. Make sure whatever data you're putting into your model is in exactly this order, because that's how it's going to be read. You can, if you put like weight into horsepower in that column, you can kind of mess things up. So follow the schema, and then under predict. So we don't have data on hand, so just click on cell A1, click on use sample data, and it'll kind of just pull some data from your data source. And then click on this little choose cells and click OK. It's going to select what was already there. So that has your input, you have your headers. And then for your output, go ahead and put in J1, because we just want the results to be right next to it. And you can click predict. And then basically that's how you consume your model. Super easy. You can manually put in numbers here, and then when you just put it into your inputs in this little side panel, and your outputs will spit out wherever you selected it to be. Notice the results aren't really the best, so there's a lot of room for improvement in this model, but it's the demonstration. So one thing, so I activated the machine learning platform on this particular worksheet. So in the future, if you close this worksheet and then you use it again, it will still be active. You can still use it without putting in the API keys and URL keys. So I can like email this to you and you can use it. But if you open up a new workbook, you're going to have to re-put in all the keys and everything like that. All right. And one last quick thing. If let's say you're actually putting this into production and you have a whole bunch of results and you have new data, you can put that right back into your model here. So just go back to your experiments page, click on experiment, and then go to the predictive experiment. So what you can do is if you ever make any kind of changes to your model, you can click deploy, and it'll show up as redeploy. And when you redeploy, it's going to have the same exact API keys and URL keys. So you can make changes to your model in the background, and someone you already shared it with, you don't have to reshare it. It'll just kind of be changed right under their noses without any problems. So that's just about it for Azure Machine Learning.